Okay, we're gonna talk about simplification of roots in this video. The idea is that when we have powers, powers and basically roots are opposite operations. So sometimes you can cancel the square root for some numbers, not for all of them, but for some numbers, sometimes you can cancel the square root. How does a square root and an exponent work? When you have exponents and square roots together, basically a square root, what it does is that it gets half of the exponent. So if you have, for example, a 7 raised to the power of 4, the square root is gonna basically get half of that exponent and it's gonna disappear. So you're gonna have, in the end, 7 raised to the power of 2. Basically you get half of a number. So half of 2 in this case, for example, it will be invisible 1. So when you have a square root and you have a 7 squared, the square and the square root are going to cancel technically, and you would just have the 7 alone. Now what happens if you don't have any powers? Then you leave the number the way it is. Okay, unless you can get the square root of the number, you're going to leave the number that way. What happens if we have exponents that cannot be divided by 2, for example, like number 3? If I try to get half of number 3, that's not possible. So what I do is I copy one of the 7's inside the square root, and instead of 3, now I will have 2. And half of 2 will be 1, so I will have a 7 outside. If you didn't understand that, then think like dividing by the 3 by 2 will give you 1.5. 3 divided by 2 will give you 1.5, so 1 means you have 1 7 outside. And the 0.5 means that you have a square root of the number inside. If you have an exact division like 2 divided by 2 will be 1, then it's just outside. 4 divided by 2, 2, so you have a 7 raised to 2. But 1 invisible divided by 2 will be 0.5, and 0.5 is technically like having the square root. A square root and a 0.5 exponent are kind of like the same thing. So we're going to use this idea to work to solve an exercise of operations with irrationals. When we have this type of numbers, like very big numbers, compounds, we're going to have to decompose them. Okay, how are we going to decompose them? We're going to use the process that we learned probably in primary school or in the first grades of middle school. I'm going to copy the number. I'm going to start with the 40, okay? And I'm going to draw a vertical line. I'm going to start getting halves and thirds and fifths, sevenths, etc. of this number. Okay, basically I'm going to divide it by prime numbers, being the smallest of all of them, number 2. So I'm going to begin with number 2. Okay, half of 40 will be 20. And half of 20 will be 10. Half of 10 will be 5. And 5 doesn't have half, so I'm going to use fifth because it doesn't even have third also. The only thing that 5 can be divided by is 5. So 5 divided by 5 will be 1. Once I finish dividing, I'm going to copy these numbers as exponents multiplying. So like this thing, if I multiply all of these numbers, I will get 40. So basically this is another way of writing 40. Instead of 40, I'm going to put 2. Because I have 3 number 2's, then it's going to be raised to the power of 3. The exponent will be 3 because I have 3 number 2's. Times 5. So instead of 40, I'm going to put 2 to the power of 3 times 5. So instead of 40, that's basically what I'm going to put. So instead of 40, I'm going to put 2 raised to 3 times 5. Now let's see 72. I'm going to decompose 72 the same way I did with 40. So 72, the vertical bar, and I try to get half of 72. Half of 72 would be 36. Half of 36 will be 18. Half of 18 will be 9. 9 doesn't have half, so I start working with thirds. Okay, 9 divided by 3, or third of 9, will be 3. And 3 also has third. The third of 3 will be 1. I'm going to do the same process. Instead of 72, that means that 72 is going to be equal to the product of these things. 2 raised to 3 because I have 3 number 2's. I count them and I notice that I have 3 number 2's times 2 number 3's. Yeah? So instead of 72, I'm going to put 2 raised to the power of 3 times 3 raised to the power of 2. So that's what I'm going to put. And it will look something like this. Okay? 2 raised to the power of 3 times 3 raised to the power of 2. Now I'm going to continue with the next number, 2,450. Okay? Because the number ends on 0, that means I can get half of the number. Half of 2,450 will be 1,225. And this number doesn't have half. And if you add these things, it will be like 3, 5 will be 10. Like this number doesn't have third, but it has fifth because it ends on 5. So I can get fifth part of this number, and the fifth part will be 245. Now 245 it also has a fifth part. So I can divide this thing by 5, and it will give me 49. Now 49 doesn't have fifth, but it has seventh. So the seventh part of 49 will be 7, and this one also has seventh, so the seventh part of 7 will be 1. With these numbers, I can write another way to write 2,450 will be 2 times 5 to the power of 2 times 7 to the power of 2. So instead of 2,450, I would use these numbers multiplying by themselves. Okay? So instead of 2,450, I will put 2 times 5 squared times 7 squared. Okay? Now I'm going to use the rules that I discussed before. I'm going to get some numbers outside of the square root. Remember that if it's raised to 2, then the number is going to come out. And if it's raised to 3, the number is going to come out, but there's going to be a remaining number in there. Okay? So because 2 is raised to 3, then the 2 is going to come outside, but there's also going to be a 2 inside the square root. So I'm going to have 2 outside and a 2 inside. It will look something like this. A number 2 outside and a number 2 inside. The 5 doesn't have an exponent rather than 1, so it's going to stay the same way. It's going to stay inside. Okay? So I'm going to repeat that same process with each one of them. Okay? And you can see how will it look like. Because the 2 is raised to 3, I'm going to have a 2 outside and a 2 inside. Because the 3 is raised to 2, then the 3 is going to come outside. And because I have 2 numbers that came outside, every time more than one number comes outside, I'm going to put them with this dot that means multiplication. Okay? I'm going to separate them with the dot, because if I get the 2 outside and the 3 outside and I don't put anything, it's going to look like a 23, but it's not a 23. It's a 2 and a 3. So I have to separate them with a multiplication sign. Because the 3 is raised to the power of 2, that means it comes outside completely, and there are no number 3 on the inside the square root anymore. Okay? Same way for this one, because the 2 is not raised to any power rather than 1, then it's going to stay inside the square root. Because 5 is squared, it comes outside. Because 7 is squared, it also comes outside. Because there are more than one numbers outside, I'm going to separate them with the multiplication symbol of the dot. Okay? What am I going to do next? Well, I'm going to multiply all of the numbers that I can multiply. Inside, I'm going to multiply 2 times 5. That's going to give me square root of 10. Outside, I'm going to multiply 2 times 3. That is going to give me 6. And outside, I'm going to multiply 5 times 7. That's going to give me 35. It's going to look something like this. Okay? 2 times 5, 10. 2 times 3 is 6, and 5 times 7, 35. And the square roots, I basically just copy them, and I copied the rest of the things. Okay? That's basically simplification of roots. I already simplify them once they are in this form. And once they are in this form, I can simplify like terms. Like this one has a square root of 2, and this one has also a square root of 2, so I can add them. 6 plus 35 will be 41. Remember that we never add the square roots, we only copy the square root. So this will be 2 square root of 10 plus 41 square root of 2. And that will be it. Okay, we cannot operate these ones because the square roots are different. They are different types, so that will be the answer for this operation by using simplification and these tiny properties of exponents and roots.